So in this example, we're going to find dy dx using the first principle or differentiation from the first principle. First of all, the definition for the first principle is given by, so if you're looking for dy dx will be the limit as h goes to 0 of f of x plus h minus f of x divided by h. Okay, so we're given a function, it's a matter of substituting. So our function is our f of x is the square root of x plus 1. Okay, which you can also write if you want x plus 1 power 2, same thing. So let's now find f of x plus h. Our f of x plus h is going to be the square root of, where there is x in this. Okay, we're going to put x plus h. So we're going to have x plus h plus 1. Okay, so now we go back to the definition of the first principle. Dy dx is going to be equal to the limit as h goes to 0. We have the square root of x plus h plus 1 minus the square root of x plus 1 divided by h. Now at this point, if you try to substitute where there is h, you try to put 0 to b and find, and seems like there isn't much you can do from here. So what you do, if you find yourself in this situation, you rationalize the numerator, okay, which means multiply it by a similar quantity x plus h plus 1. Okay, so I'm just copying the numerator here, but the difference will be in the sign here. Here there's minus, but I'm going to put, so I'll put an opposite sign. So if we have minus here, I'm going to put plus here, square root of x plus 1. Okay, divide by the same thing to signify that there is no, you're just multiplying this by 1, so there isn't any change that you've made. X plus 1, so this, everything here is essentially a 1, so no changes here mathematically. So let's multiply this, the numerator times the numerator. We are going to have the limit as h goes to 0. We are going to have the numerator, we have x plus h plus 1. It's supposed to be square root, let me do bracket here, minus square root of x plus 1 times square root of x plus h plus 1 plus square root of x plus 1 divide by everything, divided by h times square root of x plus h plus 1 plus square root of x plus 1. Then close the bracket. But here, when you look at the numerator, we can use the difference of two squares to evaluate the numerator. Okay, so how does it work? If you have a squared minus b squared, okay, you can write this as a minus b and a plus b. Okay, so the numerator is actually in this form, where our a is the square root of x plus h plus 1, and our b is the square root of x plus 1. So we can reverse, okay, from this expanded form to this form where we write a squared minus b squared. So we can have this as, this can become the limit as h goes to 0 of, so if you square this a, okay, you're going to have x plus h plus 1. Okay, in minus, if you square this b, you're going to have x plus 1. And then everything divide by h, we have x plus h plus 1 plus square root of x plus 1. Okay, then simplify the numerator. Simplifying the numerator, we are going to have the limit as h goes to 0 Okay, obviously the x here and this x will go, this one and this one will go because there is minus here. Then you remain with h, okay, as the only thing on the numerator. We're going to have this divided by h, square root of x plus h plus 1 plus square root of x plus 1. Then from here we can divide the h out. Then we have remained with the limit as h goes to 0. We have 1 over square root of x plus h plus 1 plus square root of x plus 1. Okay, so now where there is, we are now free to substitute. Where there's h, we can put 0 and we'll be able to evaluate our problem. So if you put 0 there on h, you put 0 there, you're going to have 1 over square root of x plus 1 plus square root of x plus 1, and then this is going to be 1 over 2x plus 1. Okay, so therefore our derivative, therefore our dy over dx is going to be 1 over 2 square root of x plus 1. So the main reason for this example is to show you that there are problems that will require rationalization. Okay, this is the punchline of this example. Okay, to be able to do this part, rationalize. So there are examples or there are problems that will require you to do this for you to properly find the derivatives.